Aloha, this is only for BC. First BC topic of the school year. How excited are you? We're doing volumes of solids of revolution, but this time we're going to introduce the shell method. Now, the shell method is just a really cool way to do some very difficult washer disk combination problems super duper fast, okay? So we've got kind of these like, hey, this is what's up. This is the shell method. Okay. Keys to the shell method. Okay. What I'm going to do is we're just going to get after it, okay? And getting after it, I think, is going to give you guys a better idea of why we use the shell method, okay? We do want to remember these, just like we have when we do the washer method, pi, capital R squared minus little r squared. Shell method is just 2 pi PhD, right? It's 2 pi PhD, okay? 2 pi PhD. So that's kind of a little remembering that we want to remember. Now, pretty much keys to the shell method. You do the shell method when, if you were going to do it using washers or disks, it ends up being a combination of the two, okay? So let's get after these 3 examples, all right? And then hopefully you'll have a good understanding of what's going on. Where's Homie Holmes? I can't find him. What's up? Well, he's on the ground. All right. Let R be the region bounded by these graphs, okay? We have 1 over x, y equals 0, x equals 1, x equals 4. So we get this region right here. I'll make it red because we always make these guys in red. Explain why the volume formed by revolving it about, we're going to revolve it about the y-axis. Okay. And you know what? I'll draw it. I'll draw it for us. What happens if I were to revolve that, right, about there? We would get some shape that looks like this. And you know what? If I started to draw my washers, it'd be washers in this case, right, class? You notice that it would break off like right here. It'd break off right there, okay? And so what happens is you have to break up an interval, and you're going to have to do a couple of intervals. And believe it or not, if you had me last year in AB, I gave you these types of problems last year as bonus on our Chapter 7 test. And I was amazingly surprised how many people were able to get the right answer. And what they do is they just broke it up. You had separate intervals for when the right minus the left were to switch off. Now, the shell method, the one tough thing about the shell method, and you'll get good at it because it's going to come up as a multiple choice question on the AP exam, is this would be perpendicular to the y-axis. So if I was using washers or disks, I would be doing dy. So if I want to do the shell method, which you're going to find out is a lot easier, we're going to take our rectangles and we're going to keep it perpendicular to the x-axis. So we're going to draw our little volume equals 2 pi PhD. So all I have to know is what this P dude is and what the H dude is. Guess what H is? H is the height. And it's easy to find the height of that guy because the height of that rectangle, depending on where it is just top minus bottom, right? So we just need to know what P is. Would be my side work for the shell method, and what my P is and my H. Now my H would just be top minus bottom. Why is it top minus bottom? Because I'm doing these in terms of x's. So that would just be 1 over x minus 0, right, class? That'd be the top minus the bottom. Now what the heck is P? Well, P is, let's say I take this rectangle right here, okay? And that rectangle would be a distance of x, okay? Or that x value minus 0, right? It's always x minus 0, x minus 0. So my P is x minus 0. So watch this. Volume equals 2 pi. And I dare you to even try doing some washers, right? Shells works out so much nicer. So we get 2 pi, we go x equals, this time it's from 1 to, 1 to 4. And then what is my P? My P is H. What is my H? My H is top minus bottom, which is 1 over x. Are you serious right now? There's no way this is a BC question. I just get 1. What the heck is the antiderivative of 1? Oh, snap. Well, that is just x. And I'm going to evaluate it from 1 to 4. So I get 2 pi, 4 minus 1. That is 6 pi. There is no way it was that okay. For sure. Nice and easy, Japanesey. So the shell method looks really difficult. And it is for really difficult disk and washer problems. But the shell method makes it that much more okay. Let's go ahead and try the next one. All right, let's roll. Okay, find the volume of the solid form by revolving the region, okay, bounded by the x-axis, that's the x-axis, and y equals sine x. So it would be that guy right there, right? And that'd be from, ooh, you better know what that is from. That would be from 0 to what, class? 0 to pi. And we're going to revolve this about the y-axis. Oh, snap. That'd be a pretty darn cool picture. Right, class? You get a little something, something like that. Oh, snap. We're going to go, yuck. Just yuck, right? We're going to have some washers. But this guy, when we're dealing with some washers, is you're going to go right minus the left, right? And if you use washers, you're going to end up having to do some inverse sine stuff. And inverse sine stuff, that's pretty going to make it impossible to do by hand, even sometimes with a calculator. So anytime I have a tough problem, hey, I might think, hey, maybe, just maybe, I could use the shell method. And what is the shell method? It's 2 pi ph. And what would this be? Well, if I did washers, it would be dy, so that means disk would be dx. Okay, which is awesome because everything is in terms of x. Once again, try getting everything in terms of y's, right? You're going to have to do a little inverse. Good luck. No, thank you. Okay, so instead, I just need to do a little bit of side work, and I just need to know what my p is and my h is. Well, my p is this distance. Remember, if I draw one rectangle right there, it's right minus left. What is that? Well, depending on where I draw that, that's x and it's minus 0, right, class? So it's x minus 0, right minus the left. And what is my h? It's simply the height. Well, what is the height? It's the top minus the bottom, and the top minus the bottom would be sine x minus 0. Not bad, not bad. So then I come up here, I go v equals 2 pi phd, right? But I'm doing it in terms of x's, so we go from x equals 0 to x equals pi. What the heck is my p? My p is x. What the heck is my h? My h is sine x. Well, we're not able to find the antiderivative of this bad boy, so on the AP test or one of my quizzes, this would be a calc question. You put that bad boy into your calculator. Sometimes we plug a pi in, sometimes we don't. This time I plugged the pi in because I've seen this on AP multiple choice questions before, and then they don't have a pi, and so you better make sure when a pi is not represented, you make sure you plug that into your calculators, okay? So, all right, shell method. I know a lot of people, first BC topic, oh, it's going to get rough. Not too bad, right? Not too bad. Nice and easy, job on easy. Oh, snap, what happens if I revolve about something other than the y or the x axes, right, class? Well, for one, oh, snap, you get some cool looking picture over here, right? Okay, that's a cool picture. Oh, that's not bad, right? I could probably easily do that using some washers. Oh yeah, that's definitely a washer problem. I would think so, unless maybe if I do washers, it's a dy, and oh snap, you can't solve that, right? You can't solve that for x. So oh my gosh, I have to do the shell method. Okay, I can do it. So let's not worry about that picture. Shell method, I don't even have to draw it, right? It's just 2 pi p h a to b, sorry, phd. And what is d? Well, if I did washers, it'd be perpendicular to the y, it'd be dy, so I do the opposite, which is dx. Now, if I'm doing a dx, this is where it can get a little bit iffy. Make sure you're very, very careful, okay? Because now what I'm revolving it about is not an axis, but it's x equals 2. Okay, but I've kind of already taught you how to do this, right, class? So here we go. We do a little side work. I got to find P, and I have to find H, right? H, easy peasy, Japanesey, right? That's just top minus the bottom, okay? And the top minus the bottom would be your x cubed plus x plus 1 minus the bottom. Well, what is the line? Well, it's x equals 1. Oh, sweet. It even cancels out and makes it more okay. All right, so that's my height, right? So that's the height of one of those. But what the heck? What is that distance? Well, that is an x, right? That's an x value. But remember, we always go right minus left. So this time my p would be 2 minus x. That's it. That's as tough as the shell method gets, class. So we got v equals 2 pi phd, but we're going to do it in terms of x's. So we're from 0 to 1. My p is 2 minus x. My h is x cubed plus x dx. You 100% should be able to do this by hand. I did it earlier, and I get an answer of, ooh, what was it? What? I get 29 over 15 pi. How about it? That is your first BC topic. That is AB 1 through 7 completely done. Let's get ready to get a little BC crazy. Do your worksheets. Ace this last test because it might get a little bit tougher from here on out. Aloha.